Hi, this is Thomas. Welcome to math class. We're working on trigonometry. The topic today is periodicity and symmetry. To begin, I'll highlight the two types of problems that we're solving when we're working with trigonometry. The context can vary, but we'll always be looking at two types of basic problems. One is going from an angle measure to a coordinate or a distance measure, and the other is going from the coordinate or the distance measure to the angle measure. When we're solving problems with trigonometry, we're doing one of these two calculations. So let's begin by talking about periodicity. Periodicity means that when I look at the circle, which is what I'm working with in trigonometry, if I start from the value of 0 and I work my way around the circle, I end up at a value of 360 degrees. I'm going to be using degree measures throughout this video, but you can apply the same concepts to radian measure. You simply convert from your degree measure to your radian measure. So in this case, I've identified that a point on the unit circle is an angle of 0 degrees as well as 360 degrees. And I can actually keep going. This is not just 360 degrees. This is also 720 degrees of 360 degrees that I want to calculate. Now let's look at how periodicity relates to our trigonometric functions. If I create a circle, and in the circle I find a coordinate that is, in this case, 45 degrees, and the coordinates in cosine and sine for 45 degrees are root 2 over 2, root 2 over 2. This is 45 degrees, as well as any multiple of 360 degrees. I can go all the way around the circle to 360 and an additional 45, so I have the same coordinates at 45 as well as at 45 plus 360, 405 degrees. There's periodicity in cosine and sine. The periodicity is based on a multiple of 360 degrees. And I'll describe this periodicity as the cosine of angle plus 360 degrees times k, which is any integer multiple I want. That's the number of rotations I'm going around the circle. One full rotation equals cosine of the angle. So as we see in our diagram, the cosine of 405 degrees, which is our original angle plus 360, is the same as the cosine of 45 degrees. We also see this is true for sine. Sine of the angle plus 360 degrees times k, multiple of revolutions, equals the sine of the angle, as we see here. At 45 degrees and at 405 degrees, we have the same values for cosine and sine. Now let's consider tangent, and I'm first going to calculate tangent of 45 degrees. This is sine over cosine, so root 2 over 2 divided by root 2 over 2 equals a value of 1. Now if I go 180 degrees to 225 degrees, and I identify my cosine and sine coordinates, these are going to be negative root 2 over 2 and negative root 2 over 2. So at a 180 degree rotation, I don't have the same sine, I don't have the same cosine, but the tangent of 225 degrees is going to be the same. It will also be 1. When I divide sine by cosine, I have a value of 1. So notice tangent is the same. Tangent has a periodicity of angle plus 180 degrees. Okay? Equals tangent of the angle. So the periodicity for tangent is half that of cosine and sine. So we see that in one revolution, we have 2 angle measures with the same tangent value. In one revolution, there are also 2 angle measures with the same cosine value, as well as 2 angle measures with the same sine value, but they're not exactly 180 degrees apart from each other. That's an important concept. Before we transition into that concept, let's summarize with an important observation. If we know the angle measure, whether it's in our example 45 degrees or 405 degrees or 4050 degrees, there is always one and only one cosine value, one and only one sine value, and one and only one tangent value. Now we're going to look at the concept of symmetry, which will help us to identify the angles in one 360-degree revolution, which have common trigonometric values. And that's coming up in the next video.